Alright, in this lesson we are going to be using the Pythagorean Theorem to tackle real-world applications, which basically means word problems. So this is where this real-world piece comes in. So the trickiest part about this is you need to decide if we're trying to solve for a leg of the triangle or a hypotenuse for the triangle. And in all my years of math, the best way I've learned to do this is to draw it out. So you don't have to be an artist to do this. You just have to sketch out a triangle that would model the situation. So you might have to reread the problem to figure it out. So in this example, the bottom of a ladder must be placed 3 feet from a wall. The ladder is 12 feet long. How far above the ground does the ladder touch the wall? So in this situation, let's just say it's a house. Okay, here's my awesome artistic ability. There's the house. Okay, we'll put a little front door on there just to make it a little better. I don't know whose house that looks like. Maybe it's a birdhouse. Okay, big bird. The bottom of the ladder must be placed 3 feet from the wall. So here is our wall. All right, this is the wall. Okay, so your ladder must be placed 3 feet from the wall. The ladder itself is 12 feet long. Now, ladders typically lean up against a wall, especially in these kinds of problems. So there's our ladder. Okay, you can make it an actual ladder if you want to, if it helps. So there's your ladder. It's got to touch the ground. So we know so far that it is 3 feet from the wall, and the ladder is 12 feet long. Okay, how far above the ground does the ladder touch the wall? So how far above the ground is this touch point? So we know that this is our missing side. So now, just like before, you have to determine, are we trying to solve for A, B, and C? All of these problems are going to give you a right triangle. So as you can see, here's our 90-degree angle, and that's going to point us to the letter C. Okay, so we know now that we have to solve for a leg. So Pythagorean theorem is a squared plus b squared equals c squared. And c squared has to be your hypotenuse. So we're going to plug that in for c, and then pick a or b for 3. We'll just call it a. So we have 3 squared plus b squared equals 12 squared. Now you're going to solve out your knowns. So that's going to be 9. This will be 144. And we still don't know b. Oops, that's a plus sign. Oh, goodness gracious. Okay. There we go. All right, now you need to get b all by itself, so you're going to subtract the 9 from both sides of your equal sign. 144 take away 9 gives us 135, which is b squared. And then your final step is going to be to square root. And again, you need the calculator for this one. Pardon me, I got to get mine started up again. Okay, so the square root of 135 is 11.6 and 618, which we're going to round to 11.62 feet. You have to put a unit of measure because this is a real-world problem. It's not just 11.62. It has to represent something. In this case, it's feet. And then you just ask yourself if it makes sense. So we're saying this wall, it reaches the wall at 11.62 feet. Our ladder's only 12 feet. So it's only a little bit taller if it were straight up and down against this wall right here. So would it make sense that a 12-foot ladder could be placed 3 feet against the wall and hit at 11.6 feet? Yeah, it's a little close, but it works. Okay, so that is our answer. So you just check it out. You can plug your numbers back in to see that it's true, but if you calculated carefully, you should be good to go. All right, here's another example. A soccer field is a rectangle 90 meters wide and 120 meters long. The coach asks players to run from one corner to the corner diagonally across. What is the distance? So I know we've got many soccer players out there. Here's a soccer field. Okay, it says right here, it's rectangle, okay, 90 meters wide and 120 meters long. So we've got our 90 meters here and our 120 meters here. Now, that's not a triangle, okay, but if you think about the problem, and you go back into it, the coach asks players to run from one corner to the corner diagonally across. So we've got our players here, okay, and they need to run across the field here. We want to know how far they're running. So now we have our right triangle, we have our two measures, and we are looking for the long side. So you're going to use a squared plus b squared equals c squared. Now you're going to take your numbers, plug them in, pick an a and a b. Again, it does not matter, just pick one. So we have 120 squared plus 90 squared, whoops, equals c squared. Now you're going to have to solve these ones out. So we have 120 squared, which is 14,400, plus 90 squared, which is 8,100, equals c squared. You're going to add those two together, which is 22,500. But that's still c squared, so your final step, as always, you're going to square root that c. Oops. Square root this. And that brings us to 150 meters. And again, just to check, make sure your numbers make sense. Would it make sense that they would have to run about 150 meters if the field was this size? I think so. All right, one final example. John leaves school to go home. He walks 6 blocks north and 8 blocks west. How far is John from the school? So, to know our coordinates, we have north, south, and then east and west. I always learned it spells out the word we. Okay, so there's our little helpful hint. So he's going to walk 6 blocks north, and then 8 blocks west. Whoops, I drew that backwards. So let me actually rewrite this 6 over here. How far is he from the school? So he started here. This is where John is, okay? And he's leaving school. So we'll do school as a rectangle. Those are, I don't know what those are, windows. There's his school. Here's his home. So that's what he walked. We want to see how far he actually is from the school. So we have to establish our right triangle, our right angle in the triangle. So we are looking for C. Okay? So you're going to use a squared plus b squared equals c squared. Pick an a, pick a b. We have 8 squared plus 6 squared equals c squared. 64 plus 36 equals c squared. And this is going to calculate to 100, which if you've been practicing this enough, and you're all stars, so I know you have, the square root of 100 is 10, no calculator needed. And this is actually what we call a Pythagorean triple. And I'm going to talk about that in just a second. So he walked 10 blocks. Okay, just make sure it's the longest side, which it is. So it looks like our answer is good to go. Now, this is called a perfect square because all of these numbers are whole numbers. So we had 8 squared plus 6 squared equals 10 squared. Okay, the numbers, there's no decimals. They all worked out to be whole numbers. And again, this is what we call a Pythagorean triple because these numbers work out perfectly. So there we go. That is how to apply real-world application. You just got to have your doodle skills going strong. And I know a lot of you like to draw, so this should be no problem for you. All right, go practice. Be awesome.